So everyone, we were talking about solving systems and we did graphing yesterday and we said like graphing's great to visualize it, not necessarily, you can move up if you'd like.
Is that 3 or 7?
I don't know, it's a 7.
What? No.
Okay, it's gonna be a long class, so just sit down there, buddy.
What?
Just sit down.
I am sitting there.
Anyways. We said graphing's nice to visualize, but I definitely don't want to graph every time. I think graphing's kind of a pain, especially if you have big numbers or fractions or decimals or just anything that you have to rearrange. It's all just kind of annoying. So we have algebraic ways to solve. One is called substitution, which we started yesterday. We'll do more of today. And the other is called elimination. So we might see that a little bit today as well and work on that Monday too. And we just want to be comfortable with solving them so we can find the answer to these systems. So I had set this one up. So you had 2 equations. So a system of equations means you have more than one. You technically can have systems with 3 equations. You do that in good old algebra 2, 3x3 system. And in the 2 equations, we have 2 variables. So that's where the issue lies because you need to solve, but you have 2 variables, which is a little tricky. So when you're using substitution, you look at your 2 equations and you start with the equation where the variable is by itself equals. It's either y equals or x equals, just depending. You can see I circled what y was equal to. And now where I see y, I'm going to replace it with 7x minus 17. Okay? So that's my main goal. What is y equal to? And I'm going to replace y with that. So now I'm going to kind of just fill in the rest of this equation. I have negative 8x plus 2y, but y gets replaced. So there's no longer a y in this equation. That's the whole reason we're doing that. So just take a minute to digest it. Where our main goal is to make 2 equations into one. We do that by saying that y is equal to this, and then replacing y with that in our new equation. Does anyone have a question with that setup? You guys writing it down?
I'm cool.
Because I will straight up make you stand in the hall during Pacific.
What?
I'll make you stand in the hall during Pacific.
Why?
Because you're just kind of annoying me today.
What? I'm the only one that talks to you.
I know, but when you talk like excessive amounts, it's like.
I'm not.
Okay.
It's only the start.
Okay.
Well.
Okay. That is the only new step. So I just want you to remind yourself, we're not doing like 8,000 things that are new. It's one thing that's new. And our new thing is making 2 equations into one. And from here, all the solving is review. We are going to distribute it. What's 17 times 2? Negative 34. I'm feeling lazy. I'm going to grab a calculator. We are going to combine like a terms. That gives me 6x. Thank you.
18.
We're going to add 34. Oops, sorry, that's a negative 16. And we're going to divide. Okay, so all the solving stuff, that's just a good old review of solving equations. That's why we kind of start with that. Now remember, you're not done. So I feel like you get to an answer, you're like, sweet, I'm done. When we get answers to systems, we need a point, because we need the point where they intersect. So I have x of that point. I need to find y, and I can find y by just plugging x back in. You could technically pick either one. I'm going to pick the first one, it just looks easier. So if you pick the second one, we would get the same answer. So x is getting replaced with 3. So it's 21 minus 17. Excuse me, y comes out to be 4.
I feel like this is like so easy, but it takes time.
Yes. I mean, it's not bad, right? Because everything from here is just solving equations. That's like all chapter 2 stuff. It's just getting that new equation. So take a moment. Make sure you're okay with that process. I need to
So x equals 3, so then you just have to plug that into the other.
Exactly, yep. So I always have to, it's kind of getting that first variable, because then once you have it, you can plug it back in to find the second one. Any questions here, any questions at home? Let me know. 5,000 things up. All right, let's try another one. So I just want you to see that sometimes it's y equals, sometimes it will be x equals. You just have to kind of pay attention. It doesn't really matter as long as you have one of the variables isolated. So let's do one with x equals. And I'm gonna have you guys try one. So let's do x equals 6y minus 24. And then x plus 4 equals 6. All right, number. All right. You should write down that problem. Organize your thoughts. When it says solve using substitution, you go to the equation where the variable is isolated. In this case, it's x equals. It makes no difference. You just have to pay attention. The last one, it was y equals, well, whatever.
Oh, I can't see.
Buddy, why don't you move up?
No, you had your hand in the way.
Oh. You mean you can't see? I know.
No, I already got it down. Too late.
I thought you like literally just couldn't see. Okay.
I mean, I think I'm gonna need contacts.
Maybe.
My eyes are going out.
Yeah, you should go to
They're
the eye
like losing
doctor.
energy.
Go to the eye doctor. Just be careful here. So for the last one, it was y equals, so we plugged it in for y. And this one, it's x equals this. So where I see x, I'm going to replace it. So you just have to pay attention type deal.
This is true.
Yeah.
I was up till 2:30 last night studying
For what?
modern world history.
Ugh.
And to find out, it's a multiple choice quiz.
Well, you still need to know what it is.
Somewhat, but not as much as I studied.
Well, you're prepared. You'll be fine.
I'm more alive right now than ever.
I can tell.
You just said you're so tired.
No, sometimes you get like crazy when you're tired. So reminder, only new step. We have two equations. We want to make one equation that we can actually solve. So we basically just want one with one variable. So if x equals this, where I see x in the second equation, I replace it with that. So once again, there's no x's. That was the point of doing that. And now we can solve. Could everyone please solve this? And can you please find x and y?
Oh no. The answer.
Oh no, that's my pencil. All right, so the solving is not new to us. We've been solving all year. It's been so much fun.
Not really.
Well, in my mind it is.
Actually, math is fun when you know it.
That's true.
Yeah, I can't say I know it.
We know.
Ooh, I'm chilly. So only new step was taking two equations, writing a new one. And then you guys are now attempting to solve. And then once you find your first variable, can you plug it back in to find your second one?
Is Tommy on there?
Shh. Shh. New rule.
What? I'll stop talking if you tell me Tommy's on there.
I don't know. I can't. I don't even have it up.
Just tell him I said hi. Hi, Tommy.
I'm smart.
You should do an attendance check. See who's napping. What?
I'll give you about another few seconds.
Do you have Savoy's?
Shh. You're really, you're killing me today.
I'm sorry. I just have a little bit of energy. Could fall asleep and stuff.
Alright, so I'm gonna start to do mine, you did yours, we'll check, we'll see if we're on the same page. And I'm gonna have you guys try to actually just set one up. Can you go from the two equations to the one, and then can you solve it? So just be careful with signs here. Two negatives do make a positive. 4 times 24 will be plus 96. I'm gonna combine those like terms and move that constant. What's that give me? Negative 20y equals negative 80. I got y equals 4.
Let's go.
Did other people get that?
Yes, I got that.
Oh, great. Fabulous. Now let's plug it in, because remember, we're not done. You need an x and a y. I usually just pick that first one because it's x equals, and I'm looking for x. So I'm going to do 6 times y, which we just found was 4, minus 24, which ends up being just 24 minus 24, which means x is the big old 0 for a final answer of 0, 4. I feel like people get freaked out with zeros. It's perfectly fine. Doesn't mean it's going through an axis. It's not a special case or anything like that. It's just 0, 4. As of right now, are there any questions on the setup of substitution problems or how we are solving them?
No, they're actually not that.
Yeah, once you kind of get that initial setup, the solving's hopefully not too terrible.
Oh my god.
Nothing? Okay. So I'm gonna have you guys try this one. From scratch here. Let's do, I don't wanna do that one, I already did that one, then I'm just gonna find a different one. Okay, hold on one second. Y equals 3x minus 14. And 6x minus y equals 23. Okie dokie. So, can everyone take the next 20 seconds? So I'll just check in before you actually get started. Can you please take those two equations and use substitution to write a new equation that you're going to be solving?
Sure.
If I said solve using substitution, what would that first step be? I just want to make sure we check and we're good with that step. Because if you're good with that step, you can basically do any of these now.
Do you like country music?
I do.
Who do you like? Do you like Luke Combs?
Yeah.
Do you like Thomas Rhett?
Yeah.
What's your favorite song by Thomas Rhett?
I mean, I would know it if.
Name 5 songs.
I'm getting abused today. I don't know what's happening.
Do you like Florida Georgia Line?
Sure.
Name 1 song.
I like everywhere. I like everyone and everything.
That's no.
I do.
No, you don't.
I do.
You're hating on me today. So.
No, that's kind of.
Huh?
So, everyone just do a quick check. Y equals that, whatever it is. Where I see Y, I'm going to plug it in, but just make sure the big thing is that you use parentheses when you plug in, because we're doing a lot of distributing. So we would end up with our new equation, which is 6x minus, this got plugged in for Y, equals 23. Does anyone have a question with getting from these two equations to that new one? All right, can you please solve it? Just be careful here, you are distributing that negative sign. So you're solving that one. And then I just want to show you what the special cases look like, so I'll do that after this one. And then if there's no questions, we're going to look at that other method. I'm going to chug along today because those snow days kind of killed our timeline here.
So, how much do we have to get through to get the pencil?
Everything.
And that is.
Are we on track? really are.
Just be careful with that minus sign or that negative sign. So I'm just gonna start to do mine as you're doing yours and we'll check in with each other.
Hugs, not drugs. Hugs, not drugs.
So 9. That might be -5. Alright, so as you're finishing up, can you please check with going up on the board? I went through, did a little solving, just be careful distributing that negative, that changes your signs for the things in the parentheses. But then I just kind of combine and do my thing. X turned out to be 3, and then just remind yourself to plug it back in and find your Y, which comes out to be -5. So if we had graphed those, which I don't really feel like doing, which is nice, it would have met at that point. Any questions on that problem? So I do want to show you what a special case looks like, because we saw 2 special cases with the graphing. We saw no solution and infinitely many solutions, and sometimes, like, it's nice when you visualize it, but like if you're solving, how do you know it's one of those, and how do you know which one it is? So let's do one right now. And once again, it's just gonna look like a normal problem. So sometimes I feel like things kind of stand out, like, oh yeah, that one's different. No, it'll just look like a normal problem, and you kind of just start and go from there. So y equals -2x plus 2, my first equation. Sorry, I'm trying to read. -6x minus 3y. Equals -6. Sorry, I'm trying to make the numbers nice for you guys. So, okay, if I'm going into it, that just looks like a normal problem. I'm gonna start with my setup. We have y equals, so I'm gonna plug it in where I see y. Or replace it, right? That's what substitute means. So I'm replacing y with -2x plus 2, and I'm just filling in the equation around that. Remember, we don't have y's anymore. That's the whole point of that step. Get rid of the y and replace it with what it's equal to. Looks like a pretty normal problem. We just start to solve. I'm going to distribute it.
Wow.
Now, when I get to the next step of combining like terms, what happens is my variables cancel. Don't write 0x, just cancel them out. Okay? You don't need, if something's not there, you don't need to write it. So they cancel out, and I'm left with -6 equals -6.
Is that infinite?
I was gonna say, if you had to guess, do you think it's no solution or infinitely many? It is infinitely many solutions.
So if you ask this on a test, can we just put infinite?
Yeah, that's fine.
Ooh.
So if -6 equals -6, it's infinitely. What would it look like if it was no solution?
Would it be,
If it was a different number.
Yeah, if they weren't equal. So -6 is equal to -6. So this is a true statement. If it's a true statement, it's infinitely many. If you got something where your things canceled and you got like 7 equals 12, that's false, right? That's not a true statement. That would be no solution. No, I'm not gonna do a whole other problem. But you know it's a special case when your variables cancel. So if they cancel, special case. If it's a true statement, it's infinitely many. If it's a false statement, it's no solution. So I just wanted to throw those out there because if you kind of see them just mixed in, it might get a little confusing. So now you at least know what to look for. Does anyone have a question right now?
Mr. Sherman?
Yeah.
Props to that kid that threw that up there. It's still up there.
What is it?
It's a little airplane.
Oh,
It's been there since
It's
the
still
start
up
of the year.
yeah, that's been there for a
I
while.
remember
Oh,
I
I found
asked
my
to like
paper
take
clips
it
over
down.
there. Yeah.
Like to start the year, but.
That's too much work.
Well, can I start my pencil in it?
Okay.
Cancel your stuff.
So substitution, we're feeling good. We're obviously gonna practice some more as we kind of move on. But I want to introduce elimination. The reason I want to do it is I want to kind of show you a setup and how annoying it would be to do substitution. And then I'll show you why elimination is a little easy. We're just gonna do like basic 2 problems just to kind of get a intro to it today, and then we'll work more with it on Monday. I
Cool exclamation.
made a schedule next week and I might just change it all, because those snow days really.
So like, what's up with our test?
Yeah, I don't know.
Just say no, cancel it.
No, you're having one, and
No.
I'm
No, but
counting it
it's all
times
good.
8,000,
It's all
because I was nice about the last one, so.
Wait,
You're
what?
counting it as
Times
8,000.
8,000 points. It's 8,000 points.
So this is like our whole grade.
No. I'm just getting aggressive, because I was nice about the last
I am
one.
so
Yeah, I definitely
confused.
failed that last one.
So the last one, we're just canceling it out?
Then the new one.
Yes.
But-
I have to have my mom yell at me.
Yes, sir.
Does it still cancel if like you did well?
Yeah.
Yeah, it doesn't, if you haven't noticed assessments, it doesn't really, it wouldn't really help your grade that much, I'm gonna be honest. Because if you did well, you probably did well on the other stuff.
Wait, did you grade them?
I did test it out for a few people's grades, and no one's more than like a point, so it was.
Wait, can you tell me my grade out there?
You can look on Power School.
Huh?
You can look on Power School.
But you didn't put them in.
I know, because I'm not grading them. Oh, I'm not gonna finish grading them if I'm not counting them.
Oh.
Why would I do more work just so?
I don't know, you're confusing me. You're telling me the wrong answer.
No, I thought you meant your grade for the term.
Oh, no.
Okay, so let me show you a problem and why substitution would be annoying. Oops, that should be a minus, sorry. It was negative 24, sorry, I'm trying to like look at this, so I have nice numbers. 9x plus 4y equals 24. Okay, so if we were using substitution and we had a problem like this, I would just be like, oh no. There's no variable by itself. Even if I wanted to kind of rearrange to get a variable by itself, it would be annoying because I'd have to move stuff and then divide stuff. So when we're talking about solving a system, we really want to focus on the setup of it. So if you have a system where one of the variables is by itself, use substitution. That makes sense because it kind of lends itself to that setup. This setup, on the other hand, I don't want to use substitution. So we have this other type of solving called elimination. Elimination is exactly what it seems like. We are going to eliminate something as the first step. For elimination, the setup, you want everything to be lined up. So you want the x's, you want the y's, you want the equals, and you want the constant. So everything needs to be lined up. And what we want to do is we want to add these 2 equations together. And in the process, we want to eliminate something. So this one's going to be magical. It's not always going to be like this, but I'll show you this one.
Thank you. You're welcome.
2x plus 9x is 11x. Okay, so that's easy. I'm really just combining like terms, right? Negative 4y plus 4y is 0y. So we say that eliminates. Once again, we don't write 0y. We say it eliminates. That's why this is called elimination. Equals negative 24 plus 24. I know we would say that eliminates. We need to put something here, so we will put a 0. You can't have a blank side of an equation. So if you have nothing, you do put a 0. Hey guys, you divide by 11 and you have x. It's 0. So if you see that setup, that way is way nicer, better, easier than having to rearrange and then do substitution. So that's why we have multiple ways depending on the setup. But we're not done, and we know we're not done because if we have an x, we need a y. This is where it's like plugging into these aren't as exciting as the other one. So pick an equation. I'll pick the first one. We're gonna plug in our x. And then we're gonna simplify and solve. 2 times 0 is just 0. I don't really need 0, right? It's not really doing anything for me. I can't really move it. So I end up with negative 4y equals negative 24. And I would divide to get y by itself.
Cool.
Isn't it? So I feel like the first step is like a little less work than substitution, but then maybe the second step is a little more work. So they kind of even out. It just really depends on the setup that you have. So I'm just going to show you one more elimination problem. And then we'll work on this on Monday. Then I think I'm going to hold off on our.
Homework over the weekend?
Dude,
I
you
have
hear
no
she
clue what
just
you're
said-
talking about. I never said anything about homework.
She said we're gonna.
I was asking.
Nah, it sounded like you look cautious.
No, I was just saying in the text form.
So I'm going to do one more, and then you guys are going to try a few problems, whether it's substitution or elimination. So once again, that was just the first one. Let's do another one similar, and we'll kind of see where this leads here. Sorry, I'm trying to make some nice numbers for you guys, so as to not torture you too much. Because if I just make them up, they're all going to be fractions. Minus 12y equals negative 4. All right, so when I look at this, I say I don't really want to use substitution. Everything's lined up. That kind of leads itself to elimination. And I say, all right, so I'm feeling good. I'm going to eliminate something. But if I add these right now, nothing eliminates. Oh, gosh darn it. So I'm going to have to make it eliminate. So basically, if something that eliminates, I want it to add to 0, right? Hey, can someone just yell out, do you want to eliminate x's or y's? It'll be the
Y.
same
Y.
work. Okay, well,
Y.
Y's.
Why?
Why the y? I don't know. We'll go with it. Think about what happened in the last problem. When we added two things, we wanted to equal 0. So for something to equal 0, you need these numbers to be the same, and then you want one positive, one negative. So if I want these numbers to be the same, I want to try to multiply the smaller number to match the larger number. What can I multiply 6 by to make it into 12?
2.
There you go. So I can't just pick one thing. We know with equations, if I do it to one thing, I have to do it to everything. The signs are already opposite, so we're good. We always need one positive, one negative. So I'm going to rewrite at this point. So this will make it kind of a little more obvious what's happening. I have 2x now, plus 12y equals negative 12. The second equation stayed the same. So the whole reason we did that step, and we'll work a lot more with that step next week, is when I add these, this adds to negative 5x, but we see that 12y plus negative 12y eliminates. So I had to kind of do one extra step to make it eliminate. It wasn't necessarily the worst step in the whole world. But our main goal is to make those numbers the same and the signs be opposite. And then on this side, I'll combine as well, and I'll get negative 30. And then that's a quick solve. X is 6. All right, that wasn't too bad.
Question.
Yep.
Oh, wait. Are we doing Y?
Yes.
Alright.
Always. So when we do y, we plug it back in. You can pick which equation. Do you want to throw one of these, I don't care. I'm going to be honest, I just always pick the one with the smallest numbers because I always find that easiest. So I'm going to pick this first original equation. I just find smaller numbers. I don't have to deal with anything too big or annoying, hopefully. So I pick my equation. I have x is equal to 6, so I'm gonna replace it. And then I'm just gonna do a little bit of solving. Move my constant. And then divide. And y would equal -2. So my final answer is the points 6, -2. Okay. So today was just an intro. We'll obviously work with that more next week. But we should have a better grasp on substitution because we did that at the beginning, and then we have just like the basics of elimination. All right, I'm just gonna leave that up for another few seconds for the people at home.